I'm Sanya, your host for the session. Welcome to another exciting session here at TestMu Conference 2024. Today, we'll explore how mutation testing can significantly enhance the reliability of your unit test. Our focus will be on Pitest, a tool that evaluates the effectiveness of your test by introducing modifications to your code to see how well your code holds up. Our speaker, Andres, has worked with diverse range of languages, including Java, PHP, Node.js, Scala, and Kotlin. Andres has been the forefront of optimizing data transfer and improving application quality since 2007. He is also an accomplished author with publications on Scala and advanced testing methods. He will guide us through the concept of mutation testing and demonstrate on how Pitest can be used to measure the improved quality of your test. Towards the end of the session, you will gain insights into different types of reports Pitest offers and learn how to integrate them with quality tools like Sonar. While Andres is presenting, please feel free to ask questions in the Q&A chat during the sessions, and we'll answer all the questions at the end of the session. Right? Over to you, Andres.
Thank you for the introduction. I think you do best than me when I try to explain what I do. Okay.
My pleasure.
Testing your test. And the title sounds funny because we create tests all the time for different purposes. But why I need to create a test to check my test? Okay, my presentation about me. Quickly, you have my contact information on the presentation. I think it's not changing. Sorry, let me check again. Now, yes. Okay, you have my contact information, my email, my LinkedIn. So if you have any question after this presentation, please contact me by any of these methods. I will try to help you as soon as possible. Okay, how is our development flow? How we create products or we create new features or improvements in our application? First, we create or develop or write the new feature or fix a bug. Everything's okay. We run and we wrote different method, different classes, depending of the language that you use. And at some point, you create test. And you have an 85% of code coverage, which is great for us. So if we have a big coverage, it's time to do something with this. You send to a partner to do a code review, and our partner say, everything's okay. I see your code coverage looks fine. So for me, deploy on production. But what happened? An exception appeared. And why an exception appeared? I have a good code coverage. Someone check if everything is okay or not, and for my partner, everything is okay. This situation could happen many times. And why this could happen? Well, there are multiple reasons or multiple ways to say, okay, something bad happened. The first one is Sonar not show me any kind of problem. Imagine that in your company, use Sonar to check the quality of your application, the code coverage, the bugs, the security issues, and many other things. But Sonar not saying nothing. Say code coverage 85% and everything looks fine. The second way to say, okay, something is wrong, but it's not my fault, is I have too many years of experience. It's the first time that this situation happened. Perhaps it's something related with the infrastructure. The code, it's okay. I have a huge number of unit tests or check if this new feature or this fix of a bug is solved. And the other way is that, okay, you think in one particular language or framework, okay, I use unit test, JUnit or Karate or any kind of things, and this framework or this library show me the code coverage, and I run the test, everything is okay. For me, it's okay. Okay, let me show you an example about why this situation could happen. This example is using Java and test like a method or a class works fine to obtain the information from a database. Everything looks fine, but if you see the last line, I only check that the response is not null. I don't check if any of the attributes that appears or I try to obtain the information from the database are populated. I only check if the response is not null or the object is not null. So the test pass, not fail, but at the same time, if I do some kind of modifications on the method that obtain the information, I never see that something fail. I don't see the problem. This situation could produce an exception on a productive environment or non-productive environment if I deploy this code or this code with this test that not check nothing, only check if the response is not null. And some reason it's my code coverage say that everything is okay. Yeah, it's okay, but you don't check nothing. Your test only see the coverage, not the effectiveness of your test. This test is not effective because not change nothing. And when you show this for a developer or a QA, say, yeah, perhaps I forgot to add some validations. You have reason. Okay. Many types of test. There are many types of tests. Yep. The unit test, which is the first step that we create to validate how our methods, how our classes, or how a small piece of code works fine or not. After that, we have the integration test that check the interaction between different layers of our application or the interaction with other systems. We have functional testing and we have end-to-end testing. And okay, most of the cases are we create a lot of tests in the first part of our testing. In the unit test, we create a lot of tests to check specific cases. The others have a specific purpose, like the end-to-end check the entire flow of our application. So if we miss something to check something, perhaps not appear an exception into in the end-to-end testing. Perhaps is a specific case that it's so strange that happened. But if we don't cover with the unit test, perhaps we see it on production. Okay, what is mutation? Well, mutation is more or less the idea of do something with our test. The idea is validate if our tests are effective or not. This is more or less, okay, how I can check if my test, in the case that I do some modification on my application, detect a problem, detect my tests are not check everything, every condition that could happen on my application. And this is more or less a common problem is, okay, a new test, I don't want to create a test because we create unit tests, integration tests, contract tests, chaos engineering, too many tests. I don't want to create a new test. I don't have time to do it. And the idea of mutation is reuse the test. You have your unit test, and the idea is not create nothing new, is take this unit test or this test and try to do something with that test and with our source code to check if the validations are okay or not. And how this works? Well, behind the scenes, this mutation takes the source code of our application and introduce some little modifications, change conditions, check the default value of a variable, or remove some piece of code. The idea is detect if the test failed in the case that you change something in the source code. And how is the process of execution this test? First, introduce some modifications that are called mutation. Each modification that exists in the source code is a mutation. Imagine that you have a piece of code and I remove one line. This is a mutation. If I add another, if I copy and paste the same block of code, it's another mutation. So it's not like, okay, I will run my test and I will do just one modification. No, the idea is do a lot of modifications at the same time to check what happened with the code. The second one is run the test with the original code without any kind of modification. It's like running our unit test without any kind of change. I suppose that all our tests passed with green, and after that, do the same, but with the source code with modification, with the source code that someone remove a line or move the order of the instructions. And after that, compare the results. Compare the original result with the result of the execution of the test with the modification on the source code, in the source code. And the last step is check what happened with the comparison. If the original test, all of the tests passed, and the mutation or the test with the mutation passed, you have a fail. Your test is not effective because the idea of this mutation test is with the original source code, all the tests will pass, and with modifications, the test need to fail. So it's so strange to say, okay, if the test fail, for us, it's okay. It's not a problem. And there is different types of mutation. It's not like one type of mutation, depending of the type of things that we want to do. The first one is the decisions. You change the conditions, like the and for ors, or invert the conditional, or add greater than instead to lower than, these kind of things. Or instead to say, okay, it's equal to, well, need to be different to. Okay, what happened with this? Instead to, perhaps our test passed, but if we change the circle, the second part, if the mutation, perhaps will fail. If our test not capture deception and say everything is okay, we have a problem. The second one, it's more or less simple. It's like things that we do usually. It's like copy and paste block of codes, remove lines, and change the order of the sentence. Imagine that you have a function or a method that at the beginning check all the attributes. if all the attributes of the method are okay or not, are different to null. Imagine that if you move this validation at the end of the method, what happened with your method, with your class? Produce an exception or not? What happened if I remove the validation instead to move it? Or what happened if I duplicate the code? These kind of things that are common mistake when we develop, the idea is like introduce it as a different type of mutation. Instead to throw an exception, I remove the throw an exception and I return the result. This is another one, is don't do nothing. The last one is value. And the idea of this is change the default value, or when you declare a variable, imagine that you declare a variable that sum something, and you, instead to put 0, you put 10. What happened with the final result? Is totally different. Our test failed or not? What happened if I execute many times the same test? Affect at some point the application or modify something in my database? This is a possible example. And why I use this? Well, with this kind of test, we improve the skills of our developers because we detect problems in our test. If I know that in the case that I move or remove something in the source code, perhaps my test don't say nothing and could produce an exception or a problem on production, it's a way to say, okay, you need to put attention when you write the test. You can use it mutation test, but the idea is show you where is the problem when you write a test. Increase the quality because we create a test with more validations that check all the possible conditions. And in the case that we modify something, the test will fail. Reduce the risk that we deploy something on production, the exceptions appear. And this is something important because reduce the time that do manual revisions. Imagine that someone in your company need to check if all the tests are okay and validate all the possible conditions and think, okay, this test makes sense, perhaps it's not okay. No, it's not the idea. The idea is, okay, you have the test, what is your code coverage? 85%, great. And which is the percentage of effectiveness of our test. If both percentage are more or less similar, means that your tests are great because cover all the different blocks of code in your application or in your feature, and also in the case that something change in the future, the test will detect or will produce an exception. Which are the problems? Because, okay, this is great. We not need to write nothing. We only need to reuse our test. But at some point, some problems need to appear. It's not like the whole grail. You need to find problems here. Well, to produce these mutations or these modifications on the source code, consume resources, consume memory, process, CPU, and many other things. It's not like, okay, I can use it all the times on my pipeline, or I can run on my local machine all the times that I want to check if everything is okay or not. No, you need to run in a specific moment. Developers need to know which thing test, which part of our test we need to validate. Perhaps not all the tests need to be mutated. I don't know, I have a test for a simple mapping. Take the values from one object and pass to another. And perhaps this not make sense that we spend resources to do a mutation test on that part. Is not applicable on black boxing, because imagine that you have a third library, is not your source code, and at some point you need to, or you want to do some modification. It's not possible. You only have the possibility to mutate the code in your application, not external libraries. So if you use, I don't know, any framework, any library, you can change that code. You only modify the code of your application. And here is another problem. If you have many mutations, so because you need to indicate or limit in some way the number of modifications that you want to do on your entire project. If you don't limit, you consume a lot of resources. So you need to consider these kind of things when you use mutation test. It's not like, okay, I see mutation test, I will apply on my project and everything will fine. No, you need to consider all these kind of things. Which libraries support this mutation test? Well, there are different libraries depending on the languages. Scala, Java, and Kotlin have one particular library, and C# and JavaScript have another one. Pitest is for the family of JVM, Scala, Java, and Kotlin. So you can use it without any kind of modifications. You can include in your project, and imagine that you want to migrate from Java to Kotlin and everything's okay. You can modify your source code and without need to change nothing. In the case of C#, Striker is the implementation for JavaScript, and C# is totally different. It's not the same. You need to do some modifications on the configuration depending on the language. Okay, let me show you an example of this. Okay. Here is the repository where I push all the API or microservices that I will use during this talk. Here you have a lot of information about the requirement, the structure of the project, the technologies, and many other things, the considerations. And here is my API, which is real and works. If I do a request, I have the response. If I put another parameter, I have another response. So it's okay, it's working, but working, it's not like, oh, everything is okay. Here is my Java application. And what I will do? Well, the first part that I will do is add the support to mutation test. I will go here and include the dependency of Pitest, then the name of the version, and at the end, on the plugin sections, I will add the mutation. The name of the dependency is Pitest Maven, and here I specify the format of the report which this tool will produce. HTML and XML in the case that you want to export this result on Sonar. Because one thing that this particular approach have is the possibility to integrate with Sonar. So you can check the code coverage and the effectiveness in the case of mutation test. And here is the target classes that I want to modify, or the source code that I want to modify, and where is the location of my test. If I execute this one with a simple ambient test, something bad could happen because you need, okay, here not produce nothing. If I refresh, not appear nothing on the source code. And this is because you need to add an extra dependency here to check if everything works fine or not. You need to add support to JUnit 5. JUnit 5 is the latest version of our framework, or the framework that, or the library to create test. So I need to add here this. I will reload the dependencies. And now I will do the same. Okay. I don't see why this not produce. Let me see what happened, because not produce the report. Okay, let me run the specific command. I will run the specific command, this one. Okay. Java minus version. Okay, is the key. Perhaps I use a wrong version of Java. Okay. Now, yes. Okay. Now, as you can see, there are a lot of mutations. Here appear the list, or all the list of the possible mutators, or the different things that execute my application. Like modify the order of the sequence of the different parameters and many other things. So at the end, you have, okay, how many tests you ran, the strength or the effectiveness of our test. So here you have a new folder on the target, PyReports. And these have an index. This index, okay, not appear, no problem. Open in the files. Here, this is more or less the report of Pitest. So you have the code coverage and how the mutators or the mutation coverage. So if you have all the package, all the information about the things that my mutator executes. So if I go to one particular class, I don't know, this one, show me in red what happened if something changed. The same happened here. And at the end, show me the problems. Okay, I remove the call for this one, this validate country, and the test passed. No fail. This one, it's okay. This one, not coverage. But as you can see, there are many other things here, which in my case, perhaps it's not okay. So you can restrict how many classes you execute. Here on the plugin, sorry, you can say, okay, I want to execute on controller and I want to execute on service. Just a small piece or part of my application. I will go to the terminal. I will execute again the same command. Okay, look this. You have the name of the folder with the timestamp where it's executed or when it's executed. We will modify this. Okay, I will here. I not exclude, sorry, exclude the classes. I only restrict the access. Sorry, it's okay. I think it's okay. It's here. Here are the classes that I need to restrict. I need to exclude here. I will exclude all the classes or the documentation classes. I will do the same, but before to do it, I will remove this timestamp, which is not good for me. I will say, okay, when you execute, please not put this. Because imagine that you run in a pipeline or you execute many times in your machine. It's not a good idea. Appear that a lot of folders here. Now makes more sense. I will open in my files. Okay. What else? Sorry, I don't show you this one. Not appear more. I exclude the class. And now not appear the documentation controller here. So I can exclude classes, method, or entire package. In my case, I only exclude one class, this one. But if you want, you can say, I don't know, this one. And you exclude the entire package. Okay, and this modify all the entire blocks, all the entire logic inside your application, not just so with this approach, with this engine, because Pitest have different engines, different ways to modify our source code takes more time to do it. And here you have a default engine, which is Gregor. Gregor do all these kind of modifications inside your application, remove the source code, duplicate lines, change the values. But you have another way to do it, which is the 𝐀𝐧𝐝. The 𝐀𝐧𝐝 here is another alternative which only modify the input and the output of the methods, not change the entire internal behavior of our application. Just, okay, what happened instead if I return null value, what happened with my test? What happened if instead to send a parameter, what happened if I send null? These kind of things, and the internal behavior not change. This modification or this approach takes less time to be executed, because here I include the dependency. This takes less time because not do all these modification or these internal modifications. I will execute with this command again, and this will take less time to be executed. Only look this, you have 6 tests. And if we remember, the first execution had 28 execution, 28 tests to check. So if I go again here to the files, okay, now the package controller not appear because I excluded. So if I go to the service, look this, the active mutators are, or this section is totally different. And why this happened? Because the engine is totally different. It's not the same. So instead to modify all this block of code, just modify these lines or these parameters and see what happened behind the scenes. Okay, what else I could mention? Well, I think we can continue with my presentation, where we can use these mutators or this mutation test. First one, in the validation, to check different conditions. What happens if our validators check if the parameters are different to null or some specific range of length? You can modify the logic and see what happened with the validations. With the adapters that interact with external communications, like database and other microservices, business logic, this totally makes sense because the business logic is the key point that our application could fail or not. And I think we need to exclude the package or the layers related with the DTOs or the entities that represent an object and don't have any kind of logic. It's like just the name of the class, the declaration of the attributes, and nothing more. Deceptions, that makes sense because only have attributes and a set of methods without any kind of logic, and some kind of external logic of our application because it's black box testing. So you can't check nothing outside of your application. You can check what happened, for example, in the case that you use Spring Boot, you can check what happened if you modify the internal code of Spring Boot. You can do it. Places where this approach could be a good idea: banks, crypto, medical institutions, airports, electrical plants, or places where we have a lot of money and it's necessary that we check that the code that we deploy on some environment, it's okay. We need to reduce the risk that someone lose a lot of money or have an accident in the case of the airports or the power plant. Some best practices that you need to consider: not run this command in every commit. Try to not think, okay, I have a pipeline. When I push some code of my application, the pipeline check if all the tests passed, check the code quality, and if everything is okay, perhaps someone want to deploy on some environment. No, try to put just in specific cases or create another pipeline that check this. Or perhaps a good idea could be run this kind of test after deploy on production. Try to consider a trade-off of this, because if you run all the times in a pipeline, you lose a lot of time to deploy on production. So it's not a good idea if you have a pipeline that have, I don't know, 10 steps to deploy on production, that you add an extra step that check if our tests are effective or not. You need to put in another place. Check the results. Try to take the report and push to Sonar. Check everything if makes sense or not, the report. Reduce the blocks of execution, as I show you. Exclude some classes that don't make sense, the entities, the exceptions, and many other things. Limit the mutation. You can, with Gregor or Descartes, you can limit the number of mutation for each method or class that you want to execute. And you can limit the number of mutation or tests that are running at the same time, because with the idea of improve the time to be executed, this mutation, perhaps at the same times you are running different mutations. So you run the mutation 1, 2, and 3, and this running or this process consume resources. So with the idea of limit the number of resources that your mutation testing consume, you can say, okay, I want to execute just 2 mutations each time. And check the results, because there are many false positive results. So you need to say, okay, this is not a false positive, this is okay, this not make sense, or in this case, or in this class, not make sense that I check the effectiveness of our test. Here are some additional resources, some books that cover different techniques of testing. The second one is here recommended because show you the way to think how to write a test, which things you need to consider, not just how to write on a particular framework or library. Is more or less like, okay, which things you need to consider, which things you need to check, or which things you need to mock, depending of the situation and depending of the different type of testing. And there are some blogs with more information about the different type of testing and how you can be more effective when you create tests. So that's it for this talk. If someone have questions or doubts, I'm open to answer.
Thank you, Andres. Thank you for that enlightening sessions. We certainly gain valuable insights into the improving quality of our test with mutation testing, and a great Pitest tool for giving a detailed report on mutation testing. Um, Having said that, let's proceed with few Q&As. I will just post it on the screen, and then I shall read it out. And yeah.
Sure.
Okay, so the first question: what are the most reliable methods of approaches to accurately measure the effectiveness of our test?
Okay, you can measure at some point when you use this kind of type of testing with the number of incidents on production after that you deploy something. In my case, when I start to use it, mutation test, the number of problems on productions reduced. I can say, okay, 5%, 50%, 100%, but it reduced drastically, because in the case that you have some step in the pipeline, you detect the problem. And if you integrate with Sonar Cube and configure the quality gate, you can restrict what is the percentage of the effectiveness that your application need to have to be deployed on some environment. So this is a possible way to measure how many deploys on production produce errors after that I use this mutation test.
Okay, thank you so much for answering this question. Proceeding, I have another interesting question here. Yeah. How do we stop testers from writing contrived tests that don't actually test anything but trick the sensors of the automated coverage tools nonetheless?
Okay, it's possible that you check everything, or you create tests for everything. At some point, you need to delegate to some tool. I don't know, if you have a team that create your unit test, which I expect that you have a team to do this. In the case that you don't have tools, it's complex, because in the common scenario is, okay, I see the code coverage locally, or if you have Sonar Q, which is great, but if not, you spend a lot of time to do it. the mutation test at some point reduce the time that you takes to check if everything works fine or not, or someone do the code review to check if everything or all the changes make sense or not.
Okay, thank you so much for the answer. I hope that answered your question, Esme. Proceeding, I have another question on CI/CD. So on your screen, how can developers incorporate mutation testing into their existing CI/CD pipelines?
If you have two different pipelines, one for the commit and another for the deploys, it's simple to implement because it's just in the case of Java or in the case of C#, depending on the tool that you use, is just a simple command which execute and push, or in fact create the report, and you can push to some tool. So it's simple. But in the case that you have just one pipeline, it's more complex because you can't execute this mutation testing all the time. Okay, you can do it, but I think the developers are not happy to wait, I don't know, 5 minutes, because in my case takes more or less 20 seconds, but it's because I have a small project with more or less 20, 25 tests. But imagine a huge application with, I don't know, 500 tests with tons of source code. It's not possible to run all the times before to deploy on production. So in the case that you have different pipelines, it's okay. Add as a next step in the pipeline of commits. I don't think that could produce any kind of problem. You can limit the number of classes or the object that you scan or do the mutation in the case that you want to implement this incrementally, because one of the problems that could appear with this situation is I scan all my tests, my source code, and every fail, and the tester, the developers try to kill you because show you a lot of problems. Perhaps the good approach is limit the number of mutation, limit the block of code to analyze. And when you are sure that everything works fine, perhaps you can expand this to other projects or to analyze all the source code in your application.
I think that that's a great answer. Thank you so much, Andres, for having this session with us. I also want to remind everyone that all our sessions are recorded and will be available on Lambda Test YouTube channel. Feel free to revisit the sessions and share them with your colleagues. Have a fantastic day. Thank you once again, Andres, for hosting this insightful session. And everyone stay tuned for more exciting sessions. Thank you.
Thank you. Bye.
Thank you. Bye.